Antioxidant, a word that may have been unusual 30 years ago, but now has made it into our everyday language. In fact, a whole new field of research in medicine has evolved around antioxidants, and it's called free radical biology. This science has described hundreds of health conditions that depend on antioxidants for their protection. And to date, somewhere between 2,000 and 4,000 antioxidant compounds have been identified. So we're not going to spend a lot of time right now explaining the details of how antioxidants work, but let's start off by saying that antioxidants work against oxidation. Antioxidant. So in order to know what an antioxidant does, we need to know what an oxidant or oxidation is. Here are a few examples. When iron rusts, that is oxidation. When butter goes bad or rancid, that's oxidation. When you cut an apple and in 20 minutes or so it turns brown, that's oxidation. So am I suggesting that you and I are rusting, going bad, and turning brown? Yes. Just look at the back of the hand of your grandmother. Those spots you see are human tissues being damaged by oxidation. Now, I'm not terribly concerned about the appearance of her hand, but when I see that, it worries me because the same process can be taking part in her lungs, in her heart, in her brain. But unfortunately, oxidation is a consequence of being alive. When we eat, when we breathe, when we exercise, when we sit in the sun, all of this produces what are called free radicals. And free radicals lead to oxidation. Again, the production of free radicals leads to oxidation. And when we produce free radicals, we set off a chain reaction where each free radical can turn whatever else it touches into another free radical, kind of like the zombies of molecular biology. Let's take a closer look. Here we see a bunch of nasty free radicals on one side and a group of nice healthy cells nearby. And a free radical drifts over and touches one of the healthy cells. And after a short while, remember when a free radical touches another molecule, it can turn it into a free radical and so on. So you end up with a damaged cell full of free radicals. And of course, you see that that cell's touching another cell. And that cell is touching yet another cell. And voila, you end up with, here you go, a black spot on the back of your hand or in your brain. So how do we stop this process? We could call on the cavalry, our good friends, the antioxidants. And here we show the original antioxidant most of us have heard of, vitamin C, looking suspiciously like a Pac-Man, and you'll see why in a moment. So here's the vitamin C, and the vitamin C will go ahead and grab onto that free radical and try to neutralize it. Well, that's great. The problem is that although it's neutralized the free radical, it's also neutralized itself. You see, its mouth is full and it can't do anything else. So at this point in time, if nothing else happens, we will just expel this free radical antioxidant complex. And what evidence do we have that we get rid of this? Well, have you ever looked at the color of your urine after you've taken a vitamin C pill? That's what you're seeing. You're peeing out your vitamin C free radical complex. And if this process stopped here, we would have to be eating fruits and vegetables all day long to keep on top of clearing out our free radicals. Well, there's something else going on that allows us not to continually have to keep eating tons of antioxidants. Now, up to this point, many people watching this will probably know this, but I'm going to show you something now that will be new to most people. Watch this. The vitamin C can find a glutathione molecule or a complex of glutathione molecules, and watch what happens. It hands the free radical off to the glutathione system. And there you go. It's liberated to continue to do more work. So it picks up another free radical and the process can continue over and over again. And what's happening is that glutathione is recharging, re-energizing, it's recycling that vitamin C molecule. So we get many, many more miles out of it. So here's the thing. It's not just vitamin C that it does this to. Every single antioxidant known to man, and as we mentioned, there's between 2,000 and 4,000 different ones, do the same thing. They unload their free radicals to glutathione. And this is the primary reason that we call glutathione the master antioxidant, because all the other known antioxidants cannot work with the presence of glutathione. Glutathione is the spring in the clockwork that drives all of our antioxidant processes. But that's not all. It may be enough to make you want to go out and raise your glutathione levels because all of your fruits and vegetables and supplements will work better. But there are other reasons to call glutathione the master antioxidant. When you think of antioxidants, what comes to mind? Well, certainly vitamin C and vitamin E, but there's so many others. Just visit your local pharmacy or health food store, visit Costco, and you'll find shelves of different antioxidants. What sets these apart from glutathione is that all of them come from what you eat. If you don't eat vitamin C, if you don't eat vitamin E, your body does not make them. They don't appear naturally. Guess what the major naturally occurring antioxidant in your body is? The one made by each cell. Of course, glutathione. In fact, all known living creatures must produce their own glutathione in order to exist. Plants, animals, birds, you name it. Here's another reason why glutathione is called the master antioxidant. It's a little bit more technical, but absolutely fascinating. When other antioxidants neutralize a free radical, they themselves become a free radical. Glutathione is the only antioxidant that does not become a free radical after it performs its job. I bet most of you didn't know that. I'll put together another video showing how this actually happens, so stay tuned. So let's just summarize. Number one, all antioxidants depend on glutathione for their normal function. This is the primary reason why it's called the master antioxidant. Number two, it's the antioxidant your body actually makes itself. Other antioxidants like C and E must be eaten to be in your body. Number three, it's the only antioxidant that does not turn into a free radical after it's spent. So please, please take advantage of this information. Do your mind and your body a big favor. Raise your master antioxidant glutathione and feel the difference. The health